All right. Good afternoon, everyone. Thank you so much for coming to our talk, Sharpen That Edge, EdgeComputeOps. We are going to talk about Kubernetes at the edge, but I mean, you've heard enough about it. We're actually going to talk more about networking problems with Kubernetes at the edge. So my name's Marino Wijay. Actually, if you want to flip to the other slide. Awesome, yeah. My name is Marino Wijay. I'm a developer / platform advocate at Solo. I focus on a variety of different things from delivering talks to talking about service meshes of VPN, et cetera. And with me I have...
Hi, my name is Kevin. I'm an architect here at Solo, which is just a fancy way of saying I work on some of our greenfield stuff. Been working with networking problems in service mesh for a couple years now, and excited to be here.
Awesome, thanks, Kevin. Can we get that second mic working too, if possible? All right, so we already know what the edge is, but I wanted to create a little bit of a background here, because when we decided we want to build our own little cloud with edge computing, with whatever options that are available to us, we have to think about the network. The network is probably the most critical aspect of it. I mean, maybe there are other perspectives on what is critical with the edge, but from my perspective, coming from a network engineering background, networking is critical to make sure that we have connectivity between our services, that we have clusters that can communicate with each other, and then a whole wealth of other things too around security, observability, automation, and operations. But one thing I want to point out is that there are a few kinds of edges. There is the content delivery style edge where you might have played with a CDN, and then there's the edge that you roll your own, where you decide, hey, I want to take complete control of my cloud environment or the cloud environment that I've built, distribute all my workloads everywhere, distribute my compute everywhere, and still have it all tied together so that I know when, let's say, app A fails, it has a place to run somewhere else, or I have a good resiliency built into my entire edge compute strategy. But before we actually dig deeper into the networking side of things, let's talk about the reasoning behind why. Why would we want to do edge compute? I mean, I think there's enough reasoning behind why we would want to do it. There's a lot of IoT, there's a lot of agricultural systems that take advantage of it. In fact, I think Stephen mentioned a few good, excellent use cases. There's an excellent talk happening later on today about a particular use case. But when we're actually starting to form our edge strategy, there are several key things we have to think about. If we're deploying to thousands of locations, we have to first understand why we want to do this. Do we have some specific applications that suffer from latency if we're having to hop across the pond? Do we have any sort of privacy or security requirements, as previously mentioned in the last talk? Or do we have any sort of concerns around running workloads close to individual users, more like a geographical distribution of our workloads and apps? But then it also comes back to people, right? Do we have enough people to support the solution that we build? Do we have the right footprint and hardware to go out and deploy? I mean, considering hardware, you have to think about procurement. You have to think about the right fit. You have to think about how much it's going to cost you from a budget standpoint to not only deploy, but also life cycle it over time. Because guess what? Hardware doesn't last forever, as we know. And most of the time you see that systems are swapped out every 3 to 4 years because of newer technologies, faster chips, more density that we require in our nodes. But that's how we arrive at edge computing. We start to see that we can pack many kinds of workloads onto a single little node that you might have seen in the last presentation, like a NUC. But we also have to consider other aspects too. How do we get services to talk to each other? Sure, we can employ traditional means of networking like an MPLS technology or some sort of VPN style technology. But then you also have to consider the other layers too, like authorization, authentication, being able to provide encryption between your services that are communicating across various edges, as well as seeing what's actually going on. Like, hey, we have an edge down, we have an app down. What is actually causing this? So as we start to dig into it, we want to focus a lot on the networking side of it, like I mentioned previously. So that falls into the realms of communication, cloud, devices, and metrics, and even security and automation. But before we dive into that, I want to just bring your attention to an existing solution today that many of you might have played with called KubeEdge. So KubeEdge is not truly Kubernetes, but it behaves and acts like it's a Kubernetes environment. And the way it works is you have a few components like edged, which effectively is the equivalent of what you would see as the Kubernetes control plane in a cluster, as well as a few other components like Edge Hub, as well as an upstream Kubernetes control plane. And the reason why you have to deploy a Kubernetes control plane is because KubeEdge acts as a translation layer so that it can simulate as if it's running as a Kubernetes cluster. There's also one more thing I'll mention in fact that there's a technology called Edge Mesh that allows for connectivity between all these different edge locations that you could deploy. But there are limitations with something around Edge Mesh, around achieving zero trust security, making sure that you can see what's actually going on and capture telemetry, KPIs, and metrics from your apps. It only provides connectivity at a very basic level. So you start to think, okay, if I want mesh-like functionality, if I want connectivity at the layer 7 level, I have HTTP communications going on all over the place, what do I do? So let's talk about the network stack first, and then we'll start to dig into how a service mesh helps with this, a true service mesh. So you think about your network stack for a second, and you could either go with cloud or x86 hardware that you procure. You can deploy a physical network or use something like SDN or a VPC. And then you could take that further and then decide, hey, I'm going to run Kubernetes, run a CNI or a container networking interface, and then a service mesh, because that completes the network stack. And the reason why that is because, yes, you can get connectivity through a CNI, you can have things talking to each other, but when we're starting to talk between various different services, we're talking thousands upon thousands of services, the mesh or the service mesh really provides a significant layer that helps us optimize those communications, secure them, and see what's going on. But let's talk about service mesh specifically and see how this helps. So in service mesh, there are 3 key things that it provides. I mentioned it already, connectivity, the security aspect, and the observability. But in order to do so, it uses something called a sidecar proxy. So you have Kubernetes, which communicates with something called a control plane, or the Istio-D control plane, because we're talking about Istio in this case. And Istio-D acts as your point of configuration, your point of management with respect to how your sidecars operate. Your sidecars are something that are deployed, these are these little artifacts that are deployed alongside your main application container, and they do all the routing, all the request responses for that service or on behalf of that service. But here's the thing, if you look on the very far left there's so many different services that are running, let's say, inside of your environment, and every service that you have gets a sidecar, so that consumes CPU and memory. Also, when you think about this from an operational standpoint, what actually happens when you onboard services that you already have deployed into a service mesh? You actually have to restart your services, and that is impactful. That's a service impact at that point, which means there could be an outage, or you actually have to schedule a maintenance to take these services offline for a short period of time so that they can come back online with your sidecar. Now, in order to get away from this, there were so many different approaches out there, but I will say that Solo and Google worked together to develop something called ambient mesh, a sidecarless approach. Now, this sidecarless approach means the sidecar proxy itself is no longer deployed. However, all the capabilities of the Istio service mesh still exist. How is this possible? So if you actually look on the far right diagram there, we have 2 things called the L4 proxy and then the L7 proxy. If you actually combine these 2, this is your sidecar, except we've just moved it away from the actual workload itself. Now, the layer 4 proxy, which we'll refer to as the Z-tunnel going forward, basically acts as the sidecar on behalf of multiple workloads that exist on the same node. So the Z-tunnel is a daemon set, and effectively will provide layer 4 connectivity, layer 4 authorization policies, as well as MTLS, so that you can still provide encryption between your services that are communicating with each other. Then when you decide you want layer 7 authorization, or you're trying to capture some level of observability at that layer, this is where you would deploy a layer 7 proxy, which we refer to as the waypoint proxy. Now, the waypoint proxy is still based on, if you're familiar with Envoy, the Envoy proxy, which effectively has always been the basis for how we do service mesh with Istio. However, with the Z-tunnel, or the layer 4 proxy, we actually developed a lightweight Rust-based proxy to strictly focus on layer 4 connectivity and that MTLS. The reason behind this was to optimize how this would work, to reduce the footprint of the actual sidecar itself, just to focus on those 2 key features. and then still ensure that we provide full service mesh functionality. Now, how does this look if we actually decide, hey, we want to deploy edge computing, we also want to use a service mesh, and then we decide, oh, we have multiple clusters. Enter multi-cluster ambient mesh. So ambient mesh is sidecarless. Multi-cluster ambient mesh or multi-network ambient mesh is the same thing, except now you're scaling with so many different kinds of clusters. They could be Kubernetes clusters that exist in your cloud platform that you built or that you're using as a service. These could be data center Kubernetes clusters or even edge clusters. But the interesting thing here is the way this all works. Now, let me describe a few components here. Now, if we focus entirely on just the edge compute cluster 1, we have a base operating system. It could be any flavor. It could be something completely locked down. We're using some flavor of Kubernetes. In the case of the edge, you may want to consider maybe something like K3D or maybe Kind. I mean, Kind is not super production, but you consider the fact that you want to use something lightweight that doesn't consume a lot of resources, but still provides you the functionality of Kubernetes. And then you also want to consider, yeah, you've got your CNI layer, but your Istio ambient mesh layer as well. So that gets deployed into the cluster. There are a few components that do get deployed, like Istio-D, as well as your Z-tunnel, because you need it between different nodes, as well as the waypoint if you decide you want layer 7 authorization. There's also one more thing that gets deployed that maybe you all have never really seen before, but it's called Istio CNI. And it actually acts as the mechanism to route traffic into the Z-tunnel from the source workload. So let's just say in this environment, book info is split up into two different clusters. Book info is just a bunch of microservices that produce a page that tells us how good this book is or several books. But we've split those services up across these two clusters. Now, how do we route to those clusters? How do we route services in the primary cluster or cluster 1 over to cluster 2? Well, obviously, we'll need access to a load balancer because that load balancer gives us that external connectivity inbound. But the other thing that gets deployed is something called the east-west gateway in Istio. So the east-west gateway services traffic that goes either from one cluster to the next cluster and ensures that we could get traffic all the way through and ensure that requests make it through the mesh. Now, how this all works is Z-tunnel is co-located with the workloads or the source workloads. The identity is captured of a source workload shared with Z-tunnel so that it can impersonate its ID. Z-tunnel will basically indicate to the other end, to the destination side, hey, I have a node I have a service that needs to communicate with you. Now, that service communicating with that destination workload needs to pass through a few things. And if you actually follow the red line, book info is communicating with a Z-tunnel. Z-tunnel is actually tunneling to the east-west gateway. The east-west gateway is tunneling to a destination Z-tunnel, which you're not seeing the Z-tunnels right now. But finally, the traffic is the traffic, while it is encrypted, is actually unencapsulated so it can be passed directly to the other services. The reverse is entirely possible too. So what you actually have here is tunneling. Are you all familiar with IPsec? Yes? Can I get some nods? Sure. This is very similar to how IPsec works. Now, interestingly enough, if you see this red line that follows all the way through to the east-west gateway and into book info, this is actually double encapsulation that we're doing here. Now, I'm going to pass it to Kevin, because Kevin's going to explain a little bit more about this double encapsulation and why we do it with Z-tunnels and east-west gateways.
Yeah. So now we can hear. Thank you for the introduction, Marino, on Istio Ambient. So again, the pitch here basically is this a couple changes, just like in the previous talk. We're working with edge devices here. We have resource-constrained environments, but we may need to actually talk to disparate Kubernetes clusters. Think about like phoning home for updates, talking from an edge device to a cloud device. One of the things that's majorly different about what we're able to do here is that when we look at this request flow, we go from, one Z-tunnel is all we need in our local, edge device or cluster, right? And everything else lives in your remote, which could be your cloud and another network. We want to make sure that these communications are secure. The real goal here is to get mesh-like functionality, standardize, but bring it to edge devices. And part of the reason we can do this, or what's improved, is that Z-tunnel or the zero trust tunnel is implicitly designed to be very minimalistic. The XDS configuration is tailored to this use case. It runs on the order of megabytes, whereas like a simple Envoy runs much larger, right? And this means that we can bring mesh functionality to devices at a much lower cost than we could before. Further, we can do it more securely than we used to. If you're familiar with Istio and how multi-cluster works for the classic sidecar model, they would do like SNI routing. There's some potential issues there with being able to like DDoS backing pods. There's no validation done once you reach the remote network. We improve on this model here with Istio ambient multi-cluster because we do this double tunnel, right? So the tunnel has two TLS encryptions and two different identities. The outer one, so on the right, you can see we have HBone outer and inner. HBone is just the Istio protocol. It's basically an HTTP connect tunnel. It just stands for HTTP-based overlay network, and that's basically what we're building here. This network of Z tunnels are basically an overlay network, and this allows us to standardize and bring our edge devices to a broader network if we want to, right? We can do all of our compute locally and on the edge device, and then phone home periodically when we need to securely. And so that outer identity is the Z-tunnel identity. It allows us to do connection reuse. If that doesn't verify, we kill the connection, and then the inner tunnel goes to the final destination, in this case, service B. Yeah, that's for this slide.
Awesome. So one of the biggest challenges is if you try to do Istio multi-cluster at scale, it actually is very challenging. There's a lot of different elements you have to consider. One of them is actually trust. Another one is automation and how you employ something like GitOps. So when you start to think at that level of scale, you're not just using a single cluster with Istio or even Istio ambient mesh or even a single edge environment. You're actually thinking about multiple edge environments. You have to start thinking, okay, how can I manage this under a single platform? So sorry, I have to plug Glue Platform because Glue Platform enables this. It takes a GitOps approach to ensuring that you could run multiple clusters, multiple edge locations, still have Istio ambient mesh in place, but you're actually using a centralized control plane to push out configurations. So if you look up at the very top, we use Glue Platform to provide a set of CRDs that effectively translate into Istio resources. Now, as long as I configure this single set of CRDs, this gets applied to the necessary edge locations as I would need it to. And because of that, now I'm actually simplifying my overall operations because onboarding becomes easier, lifecycle management of my environments running Istio becomes significantly easier, and now I can see literally every single environment under the same observability platform. So if you're starting to think about that scale, especially when it comes to service mesh and edge computing, check out Glue Platform. So with that, I'm actually going to pass it to Kevin to actually run a quick demo. And he's actually going to show you how ambient mesh works in the multi-cluster, multi-network environment. Take it away, Kevin.
Is that all big enough? I think you can see.
Yep.
Fantastic. So we should have an environment set up here, and because I'm very forgetful at typing the commands, I've kind of scripted up in advance, but this is a live demo, so hopefully it works. So yeah, I've taken the liberty of kind of setting up two clusters here for us to take a jump into. The first one here is basically like representing our remote cloud cluster. So this is, we can look at all the pods that we have. In here we have a default namespace with details, product page, ratings. This kind of just is the classic Istio, example product like service. It's not really that relevant, except that this is what we're going to query in the end. We're going to phone home to a remote service, and just like Marino had talked about, we have the CNI nodes. This ingress gateway is our ingress gateway. This is an Envoy proxy, and then we have the Z tunnels, which are the zero trust tunnels. And then in our remote cluster, in our edge cluster, it's much more minimal. So we just have Istio. We really didn't need the ingress gateway here, but we have a sleep pod. This is just representing like one process that we want to run on an edge device, and then everything else is very limited. Z-tunnel is just, the only other component that you really need to go ahead and phone home, and it's getting all that configuration pushed down by Istio-D. And so if we want to go ahead and set this up so that we can go ahead and phone home, let's go ahead and apply some configuration. I'm going to have to scroll through this so we can take a look at everything here. Starting from the top, we have an Istio gateway, which tells us to configure our ingress gateway to listen on port 15008 for HBone. This is going to help us be the destination for our traffic for decapsulating that outer HBone. We'd mentioned briefly, a double encapsulated HBone. This is telling us to listen and decapsulate that outer one, validate that Veritas traffic is coming from within the mesh. And then we have a service entry here. This is basically us defining a way for us to phone home. This is the host we're going to hit. We're going to make requests to service entry istio.io on port 9080. We're going to go to workloads that have the apps selected, and we're going to go with these identities. Istio is identity-based. We use Spiffy for identities. That's all standard and built in. And then that app is going to select here this workload entry. This workload entry in our environment, this address is the address of the east-west gateway. In this example, predetermined that this is the IP that we're going to be using. So we can go ahead and apply that configuration. And this is, going to be that source of truth for how we want to handle routing. So I'm going to go ahead and copy this command. Need a second hand. And then we can go ahead and make a request. And what we're going to see here is, it's hard to read, but what I want to highlight here is, so we're making a request to the service entry IO, that service entry host that we had defined on 9080 to the product page. The idea here is that we want to hit that ingress gateway in the first cluster and then that service in that first cluster. We're actually failing that request because of a TLS verification error. The self-signed certificate's kind of a misleading error here, but basically what we didn't do here is we've got two disjoint Istio configurations. We need to unify our root of trust. Because this is a demo, I'm going to be lazy and just copy that secret from 2 to 1, but realistically we would have generated those secrets with the same root trust. So now that we've gone ahead and done that, we should be able to move beyond that error for making requests. So we got the logs running again on the right, and we make the request again. Again, we see a TLS error, but now we're getting a different one. So again, I talked a little bit about we're doing double validation here of identity to make sure that our traffic is secure, 2 TLSs. We can see here that we have a SAN verification error, so we're basically getting the wrong identity. You can see that we expected the identity bad ingress gateway service account, but we got a good account. And so what we have here is actually a misconfiguration error. If we look on the left at the service entry that we had applied earlier, you can see that the subject alt name has bad ingress gateway. This is a bad configuration error, something that maybe we could improve upon if it were generated or handled for us by a platform. But if we want to go ahead and comply, fix this error, we can apply the new resource, and if we do that, so now that we fixed that error, we can do the same thing. And again, we're going to get an identity error. But just to highlight that we've done a double tunnel here, this error is actually a different one. It's still a SAN error, but now we've actually got an error validating the inner tunnel. So we've actually detunneled the outer one. And now we can see that we have a bad value for the surface account on the default namespace. And this identity value came from the workload entry, which was here. We had, again, misconfigured our resources with a bad value. If we go ahead and correct that, then we should be good to go. And I expect this to work. Beautiful, awesome. So we got a request served by reviews v1. This is like a full web page. We've kind of successfully demonstrated here that we're able to use HBone and go to our east-west gateway, make a multi-network request with Istio Ambient, and that's what we have here for the demo.
Awesome. Thank you so much, Kevin. So if you just saw all of that, would you be willing to sit there and do this 1,000 times over for all your edge locations? Nope, nope. This is exactly why I think y'all should come talk to us, the Solo booth, to learn a little bit more about Glue Platform and how we simplify this process. Kevin, can you switch back to the presentation? So I want to just tie off here with a few edge use cases. I'm not going to enumerate or list them all out, But I want you to think, if you currently are working for an organization that maps to any one of these use cases, yes, I'm sure you can certainly figure out the edge computing piece of it. But when it actually comes to the networking, I will be very honest with you. You will struggle unless you consider something production grade like a service mesh. So come chat with us, learn a little bit more about, if you don't know how a service mesh works, come learn from us. We can teach you a little bit more about it. We're going to be here at KubeCon for the next few days. Kevin and I are just going to be hanging around the booth. I will say, I'm actually doing a workshop tomorrow, which I think you all should come to. It's about network foundations, and that's also going to set you up to understand how a service mesh works. I can't remember where it is. It's somewhere, but it's one of the first workshops in the morning. Come check it out. But I just want to say, to wrap up, when you think about edge computing, it's not just about the number of resources you have available on your system. It's not just about the kinds of apps that you're going to deploy. But it's also about the platform that you have to consider if you're going to be managing multiple environments. It's also about the fact that you have various different connectivity options, but these connectivity options present their own challenges. For example, you might have a very far geographical edge that has very limited connectivity, and it could only use satellite internet, or it might be able to only use maybe DSL. And you have to factor that in as you're deploying your edge environment too. But understand one thing, when you have changing network conditions, the service mesh is actually going to save you. So I just want to end with, if you want to learn a little bit more about edge computing, there's a great book by Sergio Mendes. He wrote a book that's focused on K3s and Linkerd, but the concepts can still be applied to Istio, ambient mesh, as well as any kind of edge compute. And on the far right, if you actually want to look more about, or want to look into more about Istio ambient mesh, there's an ebook that you can download as well, or come by our booth. We probably might have a whole bunch waiting for you. And finally, if you want to learn more about application networking, hit up Solo Academy. I want to thank you all for your time. I want to thank Kevin for an excellent demo. I wish you all an amazing KubeEdge day and a KubeCon. Thanks, everyone.